Turbulence inversions. Turbulence from fresh to strong winds can cause mixing of the lowest levels of the atmosphere and establishes a dry adiabatic lapse rate in the lowest few thousand feet and a constant mixing ratio. If there's a mixing condensation level below the top of the mixed layer, stratocumulus may occur. An inversion results as there is a discontinuity between the air above the mixed layer and the air in the mixed layer after mixing. We can calculate what the new temperature and dew point temperature lapse rates are for a given layer of turbulent mixing using the equal area method. So for the temperature profile, we choose a dry adiabat where the areas to the left and right of that dry adiabat are equal, so areas A and B. Likewise, we can do the same thing for the dew point profile by picking the right mixing ratio isopleth, so the areas C and D are also equal. This will produce a discontinuity at the top of the mixed layer, which becomes our turbulent inversion, shown in the schematic here. So the new temperature lapse rate is the dry adiabat, and then you've got the environmental lapse rate above that well-mixed layer, and therefore there must be an inversion to join the two up. Likewise, the dew point profile. So let's look at a real example. Here we have a case where there's a low pressure system to the west of Tasmania and a strong pressure gradient between that low pressure system and the high, producing strong, fresh to strong northerly winds. You can see a subsidence inversion at 10,000 feet, and there's our turbulence inversion at about 5,000 feet. You can see the temperature profile is close to a dry adiabat, and for much of the depth of the dew point profile, it's close to a isopleth of mixing ratio. And then there's that sharp discontinuity between the two air masses, which is the turbulence inversion.